Okay, so today we're going to learn about implicit differentiation. So implicit differentiation is used to help us find the derivative of a function like this one. And in this function, we cannot solve for y. There's no way to get y completely by itself. So this type of function we call an implicit function, and we'll use implicit differentiation. Okay. And just as a note, guys, if you have not already printed out these notes, they're in the Unit 3 folder, and I would recommend printing them out, or you'll have to pause to write everything down. So when we do this, we usually find the derivative with respect to x. So when we take the derivative of y, we write y prime, or dy dx. We don't just put 1 because we're taking the derivative of y with respect to x. So when we do the derivative of y squared, we have to use the chain rule. So the outside is the squared part. So we make it 2y, and it's going to be to the first power, so we don't write it, using the power rule. And then we have to multiply the derivative of the inside, which is y prime, the derivative of y. And we have to do this whenever it's with respect to x. And we know that because it says d dx. Okay, you can also write it as 2y times dy dx. It's just a preference of whatever notation that you want to use. So we're going to do these 4 steps whenever we have an implicit function that we can't necessarily solve for y, or it takes too much time to solve for y. So in this case, we have x squared plus y squared equals 1. So step 1 is to take the derivative of both sides with respect to x. So I'm going to take the derivative of x squared, which is 2x. And then because we're with respect to x, we don't need to put dx over dx or x prime because it's just 1. And then I'm going to put plus the derivative of y squared is going to be 2y. And then we're going to put y prime or dy dx. I'm just going to put dy dx for now. And then is equal to the derivative of 1 is 0 because it's a constant. Okay, so that's our step 1. Step 2 is get all the y prime or dy dx on the same side of the equation. So if you forget in step 1 to multiply by the dy dx, you won't be able to do the rest of the problem. So make sure that you remember chain rule whenever you're taking the derivative of y, and you put y prime or dy dx. So now I'm going to solve for dy dx. So in this case, it's not too hard. I'm going to subtract the 2x to get it on the other side. And then I'm going to divide by the 2y. And then I'm going to simplify it. It depends on the problem. If it's free response, again, you don't have to simplify it. So it's negative x over y. Step 3 we don't have to do in this case, but it will come up a lot. So factor out the y prime or dy dx, and I'll show an example on the next few slides of this step. And then solve for y prime or dy dx, which we were able to do all by step 2 in this case. So this is my derivative. My derivative is negative x over y. And with implicit, most of the time you will have an x and a y in your answer. Okay, so we're going to do the second one. So again, this equation, I cannot solve for y. So I'm going to take the derivative of it using implicit differentiation. So the first step is take the derivative of each term, and whenever I take the derivative of y, I have to multiply by dy dx or y prime. Okay, so I get 4y cubed dy dx plus, now I have x times y, which means it's the product of 2 functions, which means I must use product rule. So when I do product rule, I'm going to do the first times the derivative of y, which is going to be 1 times dy dx, plus the derivative of x, which is 1 times y. So that's my product rule. So this is all the left side. So then I'm going to take the derivative of the right side, which is easier because it's just in terms of x. So I get 3x squared minus x, and the derivative of 2 is 0. So then our step 2 again is to get all the dy dx's on the same side. So I have dy dx in my first term, second term, my third term doesn't, so I need to move it to the other side. So I get 4y cubed dy dx plus x dy dx. And then I'm going to subtract y from both sides. So I get 3x squared minus x minus y. So I just move this y to the other side. So now we're going to have to do step 3 and 4 on that list from before. So step 3 was to factor out the dy dx or y prime. So I'm going to factor out dy dx so I get it by itself. And so I'm left with 4y cubed plus x. And then the left side stays the same, or sorry, the right side stays the same. And then our fourth step was to get dy dx by itself. So in this case, I'm multiplying these two, so I need to divide. So I'm just going to divide everything by 4y cubed plus x. Okay. And then this is going to be my answer. Okay. So make sure, if you're not sure what we did, pause it and re-look over it and make sure you write down all the steps. But when you get your answers, they're generally going to be pretty messy and they're going to have x and y's and they're not really going to simplify. So this is my derivative, and then the part B of this question says find the equation of line tangent and normal to the curve at the point 1, 1. And the curve they're referring to is this one up here. So that means we have our x here. We have our y value, so this is our a and f of a, but we still need to find f prime of a, which is f prime of 1, which in this case is going to be the derivative, which is here at 1, 1. So I'm going to plug in 1, 1 for this derivative. So how they actually write it, instead of f prime, since we don't have f, they would write dy dx and then put a little bar, and then put 1, 1 as my point. So I'm going to plug 1 in for x and 1 in for y in my slope, which is up here. So I'm going to do 3 times 1 squared minus 1 all over 4 times 1 cubed plus 1. And then I'm going to simplify to get my slope. So I should get 1 over 5, and that is my slope. So then my tangent line, if I do it just like before, nothing else has changed at this point, it's y equals my slope times x minus my x-coordinate, which is 1, plus my y-coordinate, which is 1. And then for normal, once we have that, normal is really easy. My normal line is y equals, we do the opposite reciprocal of the slope, so that's negative 5, and then everything else stays the same as long as I leave it in point slope form. Okay, and again, if you need to pause and go back to see here our answers or to have time to write it down, please pause and make sure you have this. Okay, so then the next example, we have another curve, and it says find the slope. So remember, slope just means derivative of x squared plus y squared equals 25 at 3, negative 4. So just like always, we first have to take the derivative before we can find the slope. So I'm going to take the derivative of this function. It's very similar to number 1. So the derivative of x squared is 2x, and then plus, when I take the derivative of y squared, I'm going to use chain rule again. I'm going to do 2y. In this case, I'm just going to do y prime. Again, it does not matter if you use y prime or dy dx, especially if it just says find the slope. And then equal 25, the derivative of 25 is 0. Okay, now I'm going to, again, solve for y prime. So I'm going to subtract my 2x to get it to the other side. So it's negative 2x, and then I'm going to divide by 2y. To both sides, and then again, it depends if multiple choice or free response, but I'm going to simplify and you get negative x over y. And then I'm going to use this point to find my slope, and so I'm just going to plug that in. So I get x is going to be 3 and y is negative 4, and if I reduce, I get 3/4, and that is my slope of my curve at this point. So again, if you need to pause it or go back and rewind, please do that. Okay, so then there's another one that says find d squared y dx squared. So that means find the second derivative of this function. So again, for this function, I'm going to take the derivative and use my steps for implicit to solve for y. So we already did the first derivative, which was negative x over y. For these, you always want to simplify as much as you can before you take the second derivative. Okay, so I get that. So then my second derivative, the second derivative of y, or the derivative of y prime is y double prime, or I'm going to use the notation that they gave us, which is this. So this is the same as dy dx. Okay, and then if I take the derivative of dy dx, I get the second derivative, which is this. So then I have a fraction, which is a quotient, so I have to use quotient rule. So I'm going to do low times the derivative of high, which is negative 1, minus high, which is negative x, times the derivative of y, which we're going to write dy dx, all over low squared, which is y squared. Okay, so we get that, and then when we do second derivative, we don't want dy dx in there. We have to get it all in terms of just x's and y's. So I know what dy dx is. Dy dx is my original derivative, which is negative x over y. So I'm going to plug this in for that to get my second derivative. So I get the d squared y dx squared for my second derivative. I'm just going to make this negative y. I get minus a negative, so I'm going to make that plus x times this function, which is negative x over y, and then I have it all over y squared. So for a free response, you can leave it like this, but these are generally on multiple choice, so I'm just going to simplify it so we can see what our answer would be on multiple choice. When they simplify this, they would get a common denominator. So they would multiply this left one by y over y to get a common denominator. And that leaves us with negative y squared over y minus x squared over y. I just multiplied these all over y squared. And then if I add my fractions now, I would get negative y squared minus x squared over y squared, and then to multiply by the reciprocal, we put this over 1 because these stay together as a unit. So the second derivative would be negative y squared minus x squared all over y times 1 over y squared, which gives us negative y squared minus x squared over y cubed. So we get that. Now the other thing they occasionally do, and they might in this on a multiple choice, is what they would do is they'd factor out my negative 1. And if I factor out my negative 1, I would get x squared plus y squared, or y squared plus x squared. They're the same thing. And what happens is x squared plus y squared, if we go up to our original function, they told me was equal to 25. So there's one question in the book on multiple choice that they do this. They replace this x squared plus y squared with 25 because in the original problem, that's what they told us it was. And then this is the answer. Negative 25 over y cubed that they give for the second derivative. So that's kind of a trick they do on multiple choice questions occasionally, but it's very rare, but it does happen on one question in your book. Okay, so again, if you need to look over it, just pause and rewind and make sure you have every step down. Okay, so then the next example says, find the points on the graph of y squared equals x cubed minus 3x plus 1, where the tangent is horizontal. Okay, so tangent is horizontal, we know, means the slope is 0, and slope is the derivative. So we need to take the derivative of this. So again, when I do y squared, I'm going to do 2y times y prime, because I always need to multiply by y prime or dy dx when I take the derivative of y. And then this side is all x's, so it's just normal. So 3x squared minus 3, the derivative of 1 is 0. I'm going to solve for y prime. So I get 3x squared minus 3 all over 2y. And now I have to figure out where the tangents are horizontal, so that means this slope is equal to 0. And then for a fraction to be 0, all we care is about the top, because if I multiply both sides by 2y, 0 times 2y is 0. So it's just 3x squared minus 3 equals 0. You can either factor it or just solve, it doesn't matter. So I get 3x squared is equal to 3, so x squared is equal to 1, and then remember when you take the square root, you need plus or minus. Okay, you could also factor out a 3 and then make it x minus 1, x plus 1 to solve it, and then you again get your two values of 1 and negative 1. Okay, so that's where the tangent line is horizontal. These are just the x-coordinates, which is fine. If you had to find the y-coordinate, then you would plug 1 and negative 1 into your original function and solve for y. Okay, so then another one, find dy dx of the following function. So please pause and try this on your own, and then come and watch the video to see how to do this problem. Okay, so first pause it and try it before you watch it. So after you've done that, when we take the derivative, just to review, the derivative of tangent is secant squared, and then we're doing chain rule, so I'm keeping the inside the same, but when I do the inside, I have product, so I have to do, this is going to be a long one, the derivative of a product, so I have to use product rule. So I do first times the derivative of the second. I'm going to use dy dx because that's what they told me to use in the problem. If they don't, it doesn't matter. Plus first times the derivative of the second, which is 2x. That's all my product rule. That's the derivative of the inside. Again, that secant squared x squared y is all multiplied by that. And then I'm going to do the derivative of the other side, which is 1 plus the derivative of y is dy dx. Okay, so this one's a little bit more complicated. We have to get all the dy dx's on the same side. So I could divide by secant squared, but then I have it over here and it's with the dy dx. So I need to be able to separate these two things. So what I'm going to do is I'm going to distribute the secant squared so that I get it multiplied by both of these. So I'm going to put the x squared first. So I have x squared secant squared of x squared y, and that's all times dy dx. And then plus, I'm going to distribute this, so I get 2xy secant squared of x squared y. And then the right side stays the same. Okay. So now, again, I have to get dy dx on the same side. So I'm going to move the part without a dy dx on the left to the right, and I'm going to move the dy dx to the left. So I'm going to subtract this from both sides. Okay, and you don't have to show this if you can do this in your head. So I get x squared secant squared x squared y dy dx, and then is equal to 1 plus dy dx, and then minus the same thing. And then I still need to get this dy dx to the other side, so I'm going to subtract it. Again, you can show that in one step above if you can do that in your head. Okay, so I'm just subtracting the dy dx to the other side. And then the second last step is factor out a dy dx because we need to get it completely by itself. So I'm going to factor that. And unfortunately, these are pretty long problems. When you factor out a dy dx from itself, don't forget you get 1. And then the last step is to get dy dx by itself. I'm going to divide. So again, this answer is going to be very messy, but we just leave it like that. The hardest part of these problems is solving for dy dx. You need good algebra skills to do that for some of these. And again, we're just going to leave our answer like this. They would very rarely simplify this, so it would just stay like that. Okay. That's one of the harder problems with it. Okay, and then the next example, we're going to find dy dx for the following equations. So again, please try this and then check your answer. So to do this one, we do chain rule for this. So I'm going to bring the first part, I'm going to rewrite it. You don't have to if you can see it without it. Okay, so the first outside is the 3. So I'm going to bring the 3 down. I'm going to keep the inside the same, and I'm going to make it to the second power. I still didn't take the derivative of y yet, so I don't need dy dx. Then I'm going to take the derivative of the next inside, which is sine. The derivative of sine is cosine. Keep the inside the same, which is 3y. And then I still need to multiply by the derivative of 3y, which is 3 times dy dx, or y prime. And again, I'm using dy dx because that's what they specified in the directions. So that's my left side, and then derivative of x plus y is 1 plus the derivative of y is dy dx. Okay? So then I have to get all the dy dx's on the same side. So I'm going to just kind of multiply my like terms here. So I get 3 times 3, which is 9, and then I'm going to rewrite it as sine squared of 3y cosine of 3y dy dx. And then I'm going to subtract this dy dx to the other side to get it on the same side as equal to 1. Step 3 again then is to factor out dy dx, so I'm going to factor that out. Right, don't forget your minus 1 when you factor out it from dy dx, and then the last step to get it by itself, I'm going to divide. Again, very messy answers, and you can't really simplify, which is fine. Okay, so that would be your answer. So that's all on implicit differentiation. Please make sure you pause and rewind for parts that you didn't understand, and then bring your textbook to class next class, because we're going to practice the homework all next class to make sure that you understand this. Okay, I hope you have a great day.